This is another question from the polynomial equations. It says in the equation x cubed plus ax square plus bx plus c is equal to 0, the coefficients a, b, c are real. They are real. It is given that all the roots are real and greater than 1. The roots are real and they are greater than 1. Prove that a is less than minus 3. We have to first prove that a is less than minus 3. Then we have to prove, he says, by considering sum of the squares of the roots, prove that a square is greater than 2b plus 3, 2 marks. Then third is, by considering the sum of the cubes of the roots, prove that a cube is less than minus 9b minus 3c minus 3. So first we have to prove first the equation given as x cubed plus ax square plus bx plus c is equal to 0. Let its roots be alpha, beta, gamma, where alpha is greater than 1, beta is greater than 1 and gamma is greater than 1. Now I can say sigma alpha means sum of the roots will be equal to minus a, sigma alpha beta is equal to b, and alpha beta gamma is equal to minus c. So let its roots be alpha, beta, gamma, where alpha is greater than 1, beta is greater than 1, gamma is greater than 1. So sigma alpha is minus a, sigma alpha beta is equal to b, and alpha beta gamma is equal to minus c. So let us see now that what can happen in other situations. He says first thing is we have to prove that a is less than minus 3. So first sum of the roots is sigma alpha is minus a. So I can say alpha plus beta, this is the first part I am doing, plus gamma must be equal to minus a. But alpha plus beta plus gamma must be greater than 3. So I can say instead of alpha plus beta plus gamma, why they are greater than 3? Because you know alpha is greater than 1, beta is greater than 1, gamma is greater than 1. So their sum must be greater than 3. So this will be minus a is greater than 3. So I will say a is less than minus 3. When you multiply by negative sign, the sign of inequality changes. It's minus. So this is plus and this is plus. This is no minus, but sign of inequality changes from greater than to less than. So this we proved. We suppose that the equation is this one. It is the roots alpha, beta, gamma, where alpha is greater than 1, beta is greater than 1, gamma is greater than 1. Then we proved sigma alpha is minus a, sigma alpha beta is equal to b, and alpha beta gamma is equal to minus c. Then we proved alpha plus beta plus gamma is minus a. So we just proved alpha plus beta plus gamma is greater than 3. So minus a is greater than 3. So a is less than minus 3. That is the thing. Now the second part we have to prove. But before proving second part, I will be writing some values here, which will be for my easy reference. First, sigma alpha is minus a, sigma alpha beta is b, and sigma alpha beta gamma is minus c, minus plus alpha beta gamma is minus c, and also we proved a is less than minus 3. These are the things we have proved up to first part. Now the second part states that by considering sum of the squares of the roots, I can say alpha square plus beta square plus gamma square will be equal to, actually it is sigma alpha whole square minus 2 sigma alpha beta. So it's alpha square plus beta square plus gamma square. Sigma alpha is minus a whole square minus 2b. So this is alpha square plus beta square plus gamma square, a square minus 2b. I'll be needing this value sometime, so I'm writing it here. I may need it, a square minus 2b. So now since alpha is greater than 1, beta is greater than 1, gamma is greater than 1, clearly alpha square plus beta square plus gamma square will be greater than 3. So I can say a square minus 2b is greater than 3. If a square minus 2b is greater than 3, so a square is greater than 3 plus 2b. A square is greater than 3 plus 2b. So, or I can say a square is greater than a plus 2b. A plus 2b. So a square is greater than a plus 2b. So we proved, sorry, 3 plus 2b. proved that a square is greater than, or I can say, sorry, it is 2b plus 3, whatever being given, it's okay. A square is greater than 2b plus 3. This is the case now, a square is greater than 2b plus 3. Now let us come for the third condition, third part. This was very easy. I think alpha square plus beta square plus gamma square, sigma alpha square minus 2 sigma alpha beta. Just put the values and you get this one, alpha square plus beta square plus gamma square is greater than 3. So a square minus 2b is greater than 3. So a square will be greater than 3 plus 2b. So a square is greater than 2b plus 3. Now let us go for the third part. Third part says that a cubed is less than minus 9b minus 3c minus 3 by considering some of the cubes. So let us see cubes. Alpha cube plus beta cube plus gamma cube minus 3 alpha beta gamma is always equal to alpha plus beta plus gamma into alpha square plus beta square plus gamma square minus alpha beta minus alpha gamma minus beta gamma. This is a very famous relationship. I can write alpha cube plus beta cube plus gamma cube minus 3 alpha beta gamma is sigma alpha into sigma alpha square minus sigma alpha beta. So alpha cube plus beta cube plus gamma cube minus 3 alpha beta gamma is minus c. Minus c is equal to sigma alpha. Sigma alpha is minus a. Sigma alpha square, this one, it's a square minus 2b minus sigma alpha beta is b. So this is alpha cube plus beta cube plus gamma cube plus 3c is equal to minus a cube plus 2ab and plus ab. So this is alpha cube plus beta cube plus gamma cube is equal to minus a cube plus 3ab minus 3c. But clearly alpha cube plus beta cube plus gamma cube is also greater than 1, because alpha is greater than 1, beta is greater than 1, gamma is greater than 1. So instead of this I can write this minus a cube plus 3ab minus 3c greater than it must be greater than 3, sorry, greater than 3. So alpha cube plus beta cube plus gamma cube is greater than 3 because each of them is greater than 1. So minus a cube, so I will write this, minus a cube will be greater than 3 minus 3ab plus 3c. So minus a cube is greater than 3 minus 3ab plus 3c. So now I'll multiply by minus, so this becomes a cube will be less than minus 3 plus 3ab minus 3c. I can just write a cube is less than 3ab minus 3c minus 3. Now only this thing. Now a is here a is less than minus 3, and what's the b? Actually I have to replace ab by what? B some way. So a is less than minus 3 if I multiply by b. Now let us see what the sign of b is. Sign of b must be, but because it's very much essential when I am multiplying a and b, because I need here the replacement of ab. Here's the b, my target minus 3 is there, minus 3 is there. Here my target is minus 9b, and here's the 3b. 3ab must be replaced by minus 9b. So let us see what I am doing. Actually sigma alpha beta means sum of product of 2 at a time, and their sum is b. Okay, now product of product, sum of the roots is minus. Okay, sum of the roots is minus, and roots are real actually, and greater than 1. It's given that all the roots are real and greater than 1. So sum of the roots are greater than 1. If the greater than 1 means their product must be positive. This is another thing. A is already negative, so sigma alpha can be negative, negative, positive. But since you can see, since alpha is greater than 1, beta is greater than 1, I can write here alpha is greater than 1, beta is greater than 1, gamma is greater than 1, then sigma alpha beta must be greater than 0 or positive. So I can say B is positive. First I proved that B is positive. When I proved B is positive, what I'll be doing now, since A less than minus 3, so I multiply this by B, it's AB is less than minus 3B. So here is 3AB, so I can write 3AB is less than minus 9B. There's no difference in sign of inequality, so 3AB is less than minus 9B. So here even A cube is less than 3AB minus 3, so instead of 3AB I can write minus 9B. I can write minus 9B, so A cube is less than minus 9B minus 3C minus 3. So it's proved. So let us see again how I proved this. First I proved alpha cube plus beta cube plus gamma cube minus 3 alpha beta gamma, alpha plus beta plus gamma, and this one, and I arrived at a result that alpha cube plus beta cube plus gamma cube is minus A cube plus 3AB minus 3C. Now this must be greater than 3. So minus A cube plus 3AB minus 3C is greater than 3. So minus A cube is greater than 3 minus 3AB plus 3C. Can I write here, suppose the value of alpha cube plus beta cube plus gamma cube is coming as minus A cube plus 3AB minus 3C. Then I'm doing it here again. Let's see how I am doing it, because I have very shortage of the place here. So let us see how I am doing. Now alpha cube plus beta cube plus gamma cube is minus A cube plus 3AB minus 3C is the value of alpha cube plus beta cube. But you can say alpha cube plus beta cube plus gamma cube is greater than 1. Why it is greater than 1? Because alpha is greater than 1, beta is greater than 1, gamma is greater than 1. So I can say minus A cube plus 3AB minus 3C is greater than 1. Sorry, 3. It must be 3. Sorry, I'm very sorry, because cube roots are each is greater than 1, so it's 3. So now I transferred. I'm doing this way. It is minus A cube will be greater than 3 minus 3AB plus 3C, or it's minus A cube is greater than minus 3AB plus 3C plus 3. I multiply by minus sign. This is A cube. Sign of equality changes, becomes less than. This is 3AB minus 3C minus 3. Now, but in my this result, I have to bring minus 9B, and here is 3AB. All other things are okay. So first I have been given A is less than minus 3 and B is positive. Why I am saying B is positive? I have given reason, because since alpha, beta, gamma all are greater than 1, hence sum of the products must be greater than 0. It means B is positive. When B is positive, I can multiply this by B, and with no sign change, so AB will be less than minus 3B. If I multiply by 3, this is 3AB is less than minus 9B. So if A cube is less than this, I can replace 3AB by minus 9B, so it will be A cube is less than minus 9B minus 3C minus 3, hence proved. So it is very much essential first to prove here B is positive, because then you have to multiply A and B together. So AB will be less than minus 3B, then multiply 3AB is less than minus 9B. Since 3AB is less than minus 9B, A cube is even less than if there is a 3AB, but 3AB is even less than minus 9B, so I can put here minus 9B. So A cube is less than minus 9B minus 3C minus 3, hence proved. That completes the answer.